Welcome to Lesson 9, Dividing Mixed Numbers. Our objective is I can divide mixed numbers by creating improper fractions and using GCF. And the only vocab word we have is improper fractions. It's review because we've used improper fractions before. We haven't done the definition for it though. So an improper fraction is a fraction in which the denominator is greater than the, let's try again. An improper fraction is a fraction in which the numerator is greater than the denominator. So for example, 5/2 is an improper fraction because the 5 is our numerator and it is greater than the denominator, which is 2. Is 1/2 an improper fraction? No, because the numerator is less than the denominator. And just a little review, when you turn a mixed number, like 1 1/2, and you're turning that into an improper fraction, you multiply the denominator to the whole number then add the numerator. And that goes over the same denominator. So our whole number is 1, our denominator is 2. So when you multiply 1 times 2, you get 2. And our numerator is 1. So now we have to take our answer here. We multiply here. We have to add 1. So 2 plus 1 equals 3. So now our answer is 3, and we bring our numerator down. So 1 1/2 is equal to 3/2. Okay, let's do a little bit more review on how to turn an improper fraction into a mixed number. You won't be doing this as much in this lesson, but I'm showing you because if it asks you to put the final answer in mixed number, but you get an improper fraction, I wanted to show you how to do that. So we're going to work again with 3/2, and we know what we're going to get when we have that number, but here's how, and kind of explaining why you would get 1 1/2, because we know it's that, because we just turned 1 1/2 into 3/2. But you just divide. So remember, when you're dividing, a fraction is just one big division problem. So it's just 3 divided by 2. That's what fractions are. They're just one big division problem. So if we were to actually do this and say 3 divided by 2, remember our numerator falls down. And now I just divide it like normal. 2 can go into 3 one time, and that would be 2. And I have a 1 left over as my remainder. And if I'm finding a decimal, I would add the decimal on my 0 and keep going, right? But no, I want to have an improper fraction. So my whole number is this 1. So 1 is now my whole number. And I'm dividing by 2. So remember how a fraction is just a division problem. So if I'm dividing by 2, so we're dividing by 2 because it's a fraction. So our denominator is 2. And our leftover, our remainder is 1. And that becomes our numerator. See how that's how we get. So 3/2 equals 1 1/2. All right, let's do unlock the problem. So both of these need to be turned into improper fractions. So let's start with 9 and 1/3. So multiply. So 9 times 3 equals 27. So now I have 9 times 3 equals 27 plus 1. So I have 27 plus 1, 28. So I have 28 over 1, no, over 3, because our denominator stays the same. Now, let's turn 1 and 1 6. So 6 times 1 equals 6. And now I have plus 1. So 6 plus 1 equals 7. So now it's 28 over 3 divided by 7 over 6, because our denominator is the same. And now I just need to divide like I normally would with fractions, which I would use KCF. So I keep 28 over 3. I change my division sign to multiplication, and I flip 6 7 6 into 6 sevenths. And then I can just multiply across. And now before I multiply, I'm going to see if I can simplify any of these, which I can. 7 can go into 28, and 3 can go into 6. So 7 can go into 28, so I can divide both of these by 7. And 3 can go into 6, so I can divide both of these by 3. So 28 divided by 7 is 4. And I still have my multiplication because I'm still multiplying. 6 divided by 3 is 2. So now we have 3 divided by 3 is 1. 7 divided by 7, I'll bring my multiplication symbol first, and then 7 divided by 7 is 1. And now I can just multiply straight across. So 4 times 2 is 8. 1 times 1 is 1. And when we have a whole number with 1 under it, that's the same as just having a whole number. So our final answer is 8. All right, let's do some steps. So step 1 is to turn all mixed numbers into an improper fraction. So in our example, we had 9 and what? 9 and 1/3. 9 and 1/3 divided by 1 and 1/6. So each one of these needs to be turned into an improper fraction. So we do that by multiplying. So we have 9 times 3, which gives us not 28, 27. And then we have to add our numerator, so 27 plus 1 equals 28. And now my denominator is the same, so it's 28 over 3. Same thing over here. I have to multiply 6 and 1. So 6 times 1 equals 6. And I have to add my numerator, so 6 plus 1 equals 7. So now I have 7 over my denominator that stays the same, which is 6. So this is my new problem. Those are my mixed numbers as improper fractions. Now I just have to divide as normal, right? Which when you divide fractions, you use KCF, which is step 2. Use KCF. So I'm going to K for keep, 28 over 3. C for change, the division sign to multiplication, and flip, F for Philippe, which would be 6 over 7. So now I have 28 over 3 times, I'm going to do big X, 6 over 7. And now I can simplify before multiplying because we're doing this problem, but remember if you rewrite it, it's 28 times 6 over 3 times 7. And we can simplify because 7 can go into 28 and 3 can go into 6. So we can simplify by dividing these by this by 3, 6 by 3, and 3 by 3, and dividing 7 by 7 and 28 by 7. So when you simplify 28 divided by 7 is 4 times 6 divided by 3 is 2. And 3 divided by 3 is 1 times 7 divided by 7, which is 1. Now I can multiply straight across. So I have 4 times 2 over 1 times 1, which would be 4 times 2 is 8, and 1 times 1 is 1. And 8 would be our final answer. Step 5 is to simplify if necessary. I guess you could say that if you had 8 over 1, you're simplifying by writing 8 as your final answer because you're not writing 8 over 1, but there's always that invisible line and 1. I did the spooky voice because it's like an invisible ghost. The invisible one. Ooh. Okay, moving on. Let's do some examples before I go completely insane. All right, here are our examples. So example 1 is 3 1/3 divided by 4. So my step is to turn all improper fractions into, my first step is to change all mixed numbers into improper fractions. So this 3 1/3 is the only mixed number I have, so it's the only one I need to change. So 3 times 3 equals 9. And then I need to add 1. 9 plus 1 equals 10. So I have 10 now as my numerator and 3 as my denominator. Now we need to divide by 4, and we would just divide like normal now. So we use KCF. So keep 10 over 3, change division to multiplication, and flip 4 over 1, because remember there's an invisible one, invisible line, and an invisible one, spooky. So now we have 1/4 because it's flipped. And now I can see if anything can be simplified, because when we rewrite this, 10 times 1 over 3 times 4. I know 4 and 10 are even numbers. They can't go into each other though, but 2 can go into both of them. So I could divide both of these by 2. And 10 divided by 2 is 5. My multiplication and 1 stays the same. And 3 and times stay the same. Now I have 4 divided by 2, which is 2. And now I can multiply straight across. 5 times 1 is 5. 3 times 2 is 6. And that's my final answer. All right, now I have 4 1/3 divided by 3/4. So I multiply my denominator by my whole number. So 4 times 3 equals 12. And I add my 1. 12 plus 1, because 1 is our numerator. And I get 13. That's my new numerator. So 13 is now my new numerator, and my denominator stays the same. So it's still 3. So now we have 13 over 3 divided by 3/4, and I can I can divide my fractions as normal, which is just KCF, which would be keep 13 over 3. Change division to multiplication and flip 4 over 3. And when I rewrite that as 13 times 4 over 3 times 3, nothing can go, 3 can't go into 4 and 3 can't go into 13. So I just need to multiply straight across. I'm going to rewrite it over here so I have more room. So 13 times 4, so I know 3 times 4 is 12. I'm going to carry my 1, and now 4 times 1 is 1. 4 times 1 is 4, plus 1 is 5. So I have 52 over 3 times 3 is 9. That's my final answer, because since I couldn't simplify here before I multiplied, I'm definitely not going to be able to simplify after I've multiplied, because if I would have been able to, I would have been able to do it here beforehand. So I know this is my final answer. If you can't simplify, then I would look back over your work here. Make sure you did all this multiplication correct. Or double check if you simplified these numbers all the way. All right, example 3 is a word problem. 6 hikers shared 4 pounds of trail mix. How much trail mix did each hiker receive? So the trail mix is being divided between 6 hikers. So I know then that what's being divided is the trail mix. So it's 4.5 pounds of trail mix that's being divided by 6 hikers. So this is being divided by 6 hikers. So I need to change 4 1/2 into an improper fraction. So I multiply my whole number with my denominator. So it's 4 times 2, which gives me 8. Now I need to add my numerator. So 1 plus 8 equals 9. 9 is my new numerator, and my denominator just comes down. Now I can rewrite this as just a division problem. And remember, we have our spooky 1 underneath. So when we use KCF, it's 9 over 2. It's our keep. Change division to multiplication. And flip 1/6. Flip is the right way to say it, actually. And when I rewrite this as 9 times 1 over 2 times 6. Now, 6 can't go into 9, but 3 can go into both 6 and 9. So I can divide both of these by 3. And 2 and 1 wouldn't work because you would just get 2 and 1 again. So 9 divided by 3 is 3. My times 1 stays the same. 2 stays the same, and so does the multiplication symbol. And 6 divided by 3 is 2. And now I can multiply across. So 3 times 1 is 3. 2 times 2 is 4. And that's my final answer, because nothing can go into 3 and 4. And that is it for this lesson. Go ahead and move on to your homework.